Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Have you ever wondered why learning something new seems so much easier when you can see and hear it at the exact same time, rather than just getting information in pieces? We often assume that multisensory learning, like combining audio and video, is inherently better just because it is richer. But is it the total amount of information that helps us learn, or is it specifically how that information is timed? Most of what we know about how people learn to categorize things comes from studies that only focus on the visual world. Think about how you learn to recognize a cat. You did not just look at photos. You heard meows, you felt fur, and you saw them move. Your brain is a multisensory expert. Yet scientists have spent decades mostly using sight alone to study how we categorize the world. This new study decided to push past that limit by looking at how our brains handle audiovisual information. They wanted to know if we learn better when the sound and the image hit our brains at the exact same moment, or if getting that same information in separate bursts is just as good. To test this, the researchers created a game where people had to learn to group sounds and shapes into categories. They set up two groups. In the first group, the sound and the image appeared at the exact same time. This is what they called the simultaneous condition. In the second group, the same sound and image were presented, but with a tiny gap between them, it was the same amount of information, just timed differently. The goal was to see if seeing and hearing things at the same time creates a more stable memory that is easier to pull up later on. One way to think about a p-value is like a fluke-o-meter. In this study, the results showed such strong consistency that the chance of it being a total accident was incredibly low. When they looked at the results after the training, both groups had learned the material well, but the real test was what happened during the generalization phase. This is the part of the study where researchers see if you can take what you learned and apply it to new, slightly different things. This is where the magic happened. The people who practiced with simultaneous sounds and images were way better at this. Even when the test used only sounds or only pictures, the simultaneous group crushed it. This suggests that our brains really value the timing of the input. When you get both pieces of information at once, your brain builds a richer, more flexible mental file that it can lean on later. When the information is scrambled or delayed, your brain might be working harder just to keep the pieces together, and that extra effort eats into the energy you have left for mastering the category itself. It is a bit like trying to solve a puzzle while someone hands you the pieces one by one, versus having all the pieces laid out in front of you at the start. Another fascinating finding was that people in the simultaneous group actually started to rely more on the sound. This is interesting because we usually think of humans as visual creatures, but because the audio and the video were locked together in time, the sound became a powerful hook for the brain to categorize the information. When things were separate, the participants seemed lost, not really sure whether to trust the sound or the visual as their main guide. So, what does this mean for you? If you're trying to learn a language, pick up a new instrument, or even just memorize a complex system, do not just flick through a slideshow. Try to engage multiple senses simultaneously. If you're watching a video about how a machine works, make sure the narration is describing exactly what you are seeing without the audio trailing behind or jumping ahead. That synchronization is the glue that makes information stick. The study also had a really smart second experiment to make sure they weren't just seeing the effects of longer practice times. They found that even when they accounted for how long someone spent looking at the screens, the simultaneous group still came out on top. That said, even good science has limits. We are all different, and these experiments were done in a controlled, lab-like environment with specific sounds and shapes. We don't know yet how this plays out with more chaotic real-world information, like learning to recognize a person in a busy, loud coffee shop. Ultimately, this paper tells us that how we feed our brains is just as important as what we feed them. The order and timing of our sensory input really dictate how well we hold on to knowledge. I think the biggest takeaway is that we should stop thinking of multisensory learning as a passive luxury and start seeing it as a precision tool for the brain. If you enjoyed this breakdown of how our minds organize the world, smash that like button and make sure to subscribe to RUBIN'S Mind Lab for more deep dives into the science of being human. Leave a comment below and let me know what is something you have been trying to learn lately, and can you combine your senses to help it stick? See you in the next one.